In this problem, we have an infinite series. The first part of the problem is asking us to test the convergence of this series. So we're going to apply ratio test, which says that limit as n approaches infinity when comparing the n plus 1 term to n term has to be less than 1 in order for the series to converge. So this expression is simply x plus 1 has to be less than 1. So therefore, x is confined between minus 1 and 0. And the second part of the problem is claiming that this is a Taylor series when this is approximated around x equals minus 1. So Taylor series for a general expression is f of x is equal to f of a, some approximation point, plus f prime of a x minus a 1 factorial plus f double prime of a x minus a 2 factorial, and so on and so on. Okay? And since the problem is asking us to evaluate what f of x is, we have to find a function f of x such that the expression for this Taylor series reduces down to the expression for this sum. Okay? First, we know that since this is approximated around minus 1, all the a's become minus 1s. 1, and this is plus 1. And now we can see this expression and this expression is identical if this is reduced to 1, this is reduced to 1, and this is reduced to 1. So we have to find the function f of x such that this f of x term satisfies all these conditions for the function itself and the derivative of the functions. Okay? So I'm going to guess function f of x that has this form, 1 minus x, 2 minus 1 power. And let's see what happens as we apply derivative onto this function. So the first derivative gives us 1 times 1 minus x minus 1. Second derivative gives us 1 times 2 and 1 minus x minus 3. Oops, yes, I forgot. Okay. And the third derivative is just 1 times 2 times 3, 1 minus x minus 4. So therefore we can see that this function pulls out the factorial factors, which will cancel out with the factorials in the denominator for this expression. But however, this function is not complete because at f of minus 1, this is 1/2, not 1. So in order to make it 1 at minus 1, we just have to multiply this by 2. now, this function pulls out the factorial factors, cancel out with denominator, as well as this function is 1 at minus 1. Okay, so from this exercise, we learned that f of x is equal to 2 over 1 minus x. And part C of the problem asks us to evaluate g at 1/2 when g of x is defined by integral of -1 to x of f of t dt. Since we already figured out that f of x is given by this expression, we just have to plug in this expression into here and evaluate the integral. So when we do that, 1x is 2, 1 minus t dt, and this expression, when we make substitution of is du is equal to minus dt, and this expression simplifies to 2 1 minus x of 2 over u over du with a minus factor put outside. Okay. And when we evaluate this integral, this is just minus 2 1 minus x 1 over u du, which is minus 2 ln of 1 minus x over 2. And the last part of the problem is asking us to evaluate h of x when h of x is defined as f of x squared minus 1. Okay. And since f of x is defined as x squared minus 1, all we have to do is plug in x squared minus 1 wherever we see x. So therefore, this is just 1 plus x squared minus 1 plus 1 plus x squared minus 1 plus 1 square and dot dot dot. And this expression is just 1 plus x squared plus x to the 4 and dot dot dot. And in summation notation, this is just sum of n from 0 to infinity of x to n. And finally, we just have to evaluate h of 1/2. Okay, so this is just f of 1/2 squared minus 1, which is f of minus 3/4. So since f of 3/4, the 3/4 gets plugged into this expression, and we have to evaluate this expression. So that's 2 over 1 plus 3/4, which is 8